Hello everybody! This is problem 8 from the fall 2020 Math 210 final exam. It's a integration by parts problem. So we know that because we have to read where it says integration by parts. And so we're trying to find an antiderivative for the sine of 3t times e to the negative t. So when we use integration by parts, we're going to have to choose some factor of the integrand to be our u and another factor to be our dv. I'm not going to make that choice uniquely. I'm going to do it both ways, just to show you it doesn't really matter when you have sines and exponentials, which one you choose as your u. So let's say first I'm going to let my u be the sine of 3t, and the dv will be the e to the negative t dt. But I'm going to use my tabular method, so I don't have to write any of the dt's or the u's or the dv's and all that jazz. So what I know is I'm going to differentiate what I choose as my u, and I'm going to anti-differentiate what I choose as my v, or my dv. So when I differentiate sine, I'm going to get cosine, but by the chain rule, I get an extra factor of 3. So I get 3 cosine of 3t. When I anti-differentiate e to the negative t, I'll get negative e to the negative t. All right, well, this doesn't really feel any better, so I'm going to use integration by parts again. I'll take another derivative, and that's going to give me now negative 9 sine of 3t. Of course, I got a negative because the derivative of cosine is negative sine. And then I integrate negative e to the negative t, and I just get positive e to the negative t. And at this point, I've essentially gotten back to my original problem. Remember, each step of integration by parts, I would be multiplying across, and now I would have sine of 3t times e to the negative t, and well, okay, there's a negative 9, but what's a constant amongst friends, right? I essentially have the original problem back. So I'm going to go into the box. All right, so this is my extra bit for my tabular method. I go into the box. I'm going to leave the negative 9 on the left. I'm going to write sine of 3t e to the negative t on the right. I'm going to give a name to this antiderivative of sine of 3t e to the negative t, so that if I continue on, my next step, the derivative of negative 9 is 0, and an antiderivative is what we call I. Okay, as soon as we get to 0 on the left, we're done. We don't have to do any more integration by parts. I start drawing my lines. Remember, you never ever have lines inside the box, because this is not me doing integration by parts. This is just me rearranging what is going to be my u and what is going to be my dv. So I can have stuff coming in, I can have stuff coming out of the box, but never any lines in the box. All right, plus, minus, plus. And so my I equals, okay, these first two terms have an exponential, so let me factor that out, e to the t, and what's left? I have a negative sine of 3t. Then I have, let's see, a minus 3 cosine of 3t. Ooh, makes me want to actually pull out both of those minuses. And then I have minus 9 times I. That doesn't have an exponential in it. Okay, well, I can now add 9i to both sides. And when I do, I'll get 10i on the left. And on the right, well, okay, now I really will pull this negative out because that makes me feel a little bit better. And I'll have sine of 3t plus 3 cosine of 3t times the negative of this decaying exponential. And then finally, I can divide by 10, and I solve for I. That's what I was looking for, right? I just wanted an antiderivative, and I wanted it to be I. And this is going to be negative 1 over 10 times the decaying exponential times the sum of the sine of 3t and 3 times the cosine of 3t. There we go. Integration by parts, a little I trick. We get to use our tabular method along with a box. So much good. Aha, but wait, there's more. I promised that I would do it the other way around, right? Instead of letting the sine of 3t be my u, I could let the e to the negative t be my u. So let's try it again. So we'll move down a little bit. I'm going to just copy the problem down. So we're going to integrate sine of 3t e to the negative t. But this time we'll let my u be e to the negative t, and dv would be my sine of 3t dt. All right, so I'm going to take a derivative of e to the negative t. I get negative e to the negative t. And an antiderivative, sine of 3t. So an antiderivative for sine is negative cosine. But this 3t has to be dealt with because when I differentiate, there'll be a chain rule, all that nonsense, right? Okay, so I'm going to have to divide by 3, not multiply by 3 like I did before, because I'm anti-differentiating, not differentiating. So I get negative 1/3 cosine of 3t. Now I apply integration by parts again. I take another derivative, and I get e to the negative t. Another antiderivative, well, this time an antiderivative for cosine is just sine, which means this negative stays out. I again have to divide by 3, so I get negative 1/9 sine of 3t. Okay, well, at this point, I'm once again in the situation where when I look multiplying across, I essentially have the original integral with this extra negative 1/9. So I go into the box, I move the negative 1/9 to the left, the exponential to the right, so that I have sine of 3t times e to the negative t. And again, I take a derivative of negative 1/9 to get 0. And now an antiderivative is exactly what I'm trying to compute. So there's my I. I draw my lines, once again, not putting lines inside the box, plus, minus, plus. And so my I is equal to, well, again, I have exponentials. And let me check, because I knew last time I had negatives each time. So here I have a positive exponential, but there's a negative. And here I have negative, negative, negative. That's 3 negatives. Okay, so I'm going to pull out a negative exponential times 1/3 cosine of 3t. And then I'll have a 1/9 plus a 1/9 sine of 3t. And then down here I have minus a 1/9 I. So minus 1/9I. All right, well, it feels a little bit different than before because I don't have 3 times like cosine of 3t, but I have fractions times it, right? 1/3 times it. And then there's like a 1/9 times sine of 3t. I didn't have that before. On the other hand, before we had minus 9i and not a 1/9 I, and that's going to compensate. So I can add a 1/9 I to both sides. And since I have 1 I and 1/9 I get 10/9 I equals negative e to the negative t times 1/3 cosine of 3t plus a 1/9 sine of 3t. Okay, now I can multiply both sides by 9/10, and that will solve for I. So I have negative 9/10 e to the negative t times 1/3 cosine of 3t plus a 1/9 sine of 3t. And if I want to make sure I'm really getting what I had up above, let me distribute the 9 inside. So I still have negative 1/10 e to the negative t. 9 times 1/3 is 3, so 3 cosine of 3t. 9 times 1/9 is 1, so plus sine of 3t. And up to the ordering, you can see there's my 3 cosine of 3t, and here's my sine of 3t, and a negative 1/10 e to the negative t on the outside. Woohoo! It works either way. Who needs the LIATE rule? T and E, man, doesn't matter what order.